All right. So yes. So it seems that most of you are here already. So let us start now our discussion for today. So before we'll start, do you guys have a question so far regarding with our past activities, our past discussions? Any
Not so far, sir.
questions? All right. Okay then. So I hope that you guys have already checked this one out, the week 2 introduction to electronics. Though I'm pretty sure that maybe 80% you guys already know what is this all about. Okay, so here's the overview of the module 2. I mean module 3 rather. So as you guys can see, we have here the topic learning outcomes and then the list of topics that we're going to discuss. And
Okay.
here are the learning resources. So of course we have the PDF, which I have already uploaded in here. So please download this one so that you can have your own copy while we are having our own discussion. And then for the video materials, so you can always visit this one, right? So just go to this page, module overview, and then just left click those links. So those are the links that will help you to understand more what is electronics all about. Okay. And then I have also, where is that one? Here. I have also included here a reading materials wherein it is a guideline on how to use the fritzing. Okay. Is there anyone here who have experience in using fritzing? Have you guys heard what is fritzing?
No, sir.
Familiar
No,
lang. Familiar lang, sir.
familiar.
No.
So fritzing is actually similar with EagleCAD, but this one is quite more user friendly. Let's say that this one is for beginners, and EagleCAD is the one that is being used in industry, okay, for professionals. So fritzing is, meron pala ako dito. Okay. Right, so fritzing is an application wherein it will give you a virtual components. Like for example, of course, you have here the real components, right? But in fritzing, you can have the virtual breadboard, virtual what is this one? I don't know, potentiometer maybe. And we have some wires, and then we have the servo motor, and then the Arduino. Okay, so like maybe 90% this one is complete if this one is updated. Okay, 90 to 95% the components that you'll be needing is already in here. Okay, so this is the first step that you might be needing when it comes to drawing a schematic, especially if you're doing it in virtual first before doing it on the actual breadboard. But you can do either of those two. But if you are more concerned when it comes to your components getting destroyed or getting uh, maybe getting failed because of your connections, then it might be safer to use fritzing first, okay, before you will do this one in actual. Okay, so as you guys can see, we have here a lot of projects, and then you can do that one also in the fritzing. Okay, so basically this one is just a brochure wherein he is saying they are saying what is fritzing, he uses fritzing, what is the use of fritzing, and what are the things that we have accomplished using fritzing, etc., etc. Okay, so mostly these are projects or workshops that we have created using this application. Okay, and here's the virtual, and then here's the actual PCB board. Okay, and what else? So yeah, I guess that's it. And then the other two reading materials is all about electronics. Okay, the basic components, how to use them, what are the usage, when to use them, etc., etc. Okay, and most of my let's say ideas came from this website. Okay, explain that stuff. Okay, so in here it's basically explaining all of the basic components, resistors, diodes, capacitors, transistors, optoelectronic, circuits and circuit boards, etc., etc. Okay, and then the history or a short history of electronics. Okay, so please visit this one. And here's now the PDF, which will be discussed later on. And then I have also included here a link, okay, where you can download and install a FreeSync, because if you're going to visit their official website, you have to pay. Okay, you have to pay for you to be able to download this one, like $8 or euro. Is this dollars or euro? That's correct, euro. Or yeah, I guess this one is euro. So 8, ano bang tawag doon? 8 pounds? Tama ba? Ganun ba yung tawag nila sa euro? 8 pounds, 25 pounds. Anyway, so yeah, you have to pay for this application, okay? But of course, we have ways to download the crack file or the crack version. Okay, so I have this tutorial on how to install and download FreeSync for free. Okay, so just watch this video. I guess this one is 4-minute video. So yeah, just visit this link. Okay, and then here's some tutorials or FreeSync tutorial on how to use FreeSync. Okay, so just click this one. Okay, so I guess this one is 7-minute video.
Hi guys, it's Roman Kotak here.
So this is just a short introduction and how to bring out the breadboard, how to go to the parts, etc., etc. Okay, and then how to put the component to your breadboard, and so on and so forth.
The properties of the resistor. For
And
example,
here's where you can edit the values, etc., etc. Okay, so everything is in here. Okay, maybe not everything, but at least the most thing that you'll be needing when it comes to creating a simple project is already there. Okay, so please do check those two. Okay, and then under watch videos, so I have also included all of the tutorials. I mean, all of the introductions, okay, that can be found on the YouTube. All right. So here's a YouTube where it will explain about capacitors. It will explain about inductors. It will explain about ICs, transistors, etc., etc. Okay. And I've also included here a FreeSync exercises. So this one is optional. Okay. So it is not completely up to you if you will do this one. Okay. So this one is a 7-slide FreeSync exercises. So we have here the introduction on what you are trying to create. So of course, you will start with a very simple project, a blinking LED on pin 13. Okay, so this one is much appreciated if you have your own Arduino. Okay, so this one is really, really useful. Okay, when it comes to starters in creating a simple project. And by the way, guys, maybe you will be having or will be adding additional topic when it comes to Arduino, okay? Because like drafting and design is related or is partnered with, okay? It's partnered with Arduino, okay? So they always go together. So the components and then how to control them using Arduino, okay? So this one is a 7-slide. Yeah, so this is another project. Where is the next button? This is another project, etc., etc. Okay, so those are just simple projects wherein, we just need simple components like servo motor, potentiometer, LEDs, resistors, and maybe some capacitors. All right. And I've also prepared the lab number 5 here. So later on, we'll talk about this one while we're discussing our module 3. And of course, there's another case study number 3. So we will discuss this one later on once we're done with our discussion. All right. So are you guys ready now to start our discussion with module 3?
Yes, sir.
Yes, sir.
Yes, sir. Good. So this one is just super simple. Okay, like this one is literally for electronics 1. Okay, so this is might be introduction that we are also using when it comes to introducing electronics. So first, let's start with an atom. Okay, what is an atom? So you guys may already know that an atom is the smallest particles that we can find, or we have ever known in our entire life. Okay, but an atom is composed of still, four parts. So we have here the electron, the nucleus, and then the protons, and then neutrons. Okay, so the protons and neutrons is the one that is on the middle, and then the nucleus is maybe the outer part, this one, and then the electron is the one that is rotating, or call this one orbiting. So the correction, orbiting uh, on these protons and neutrons. Anyway, so mostly this is what they will show when it comes to an atom. Okay, just to give you guys an idea on where is electron, where is proton, where is neutron, then where is nucleus. Okay, so let's have a short history when it comes to atom. So atom is actually the fundamental building blocks of chemistry. So I will show you guys later on why this atom is building blocks of chemistry, like the periodic table of elements. Okay, so let's start with this cookie. Okay, like in everything or in anything. Okay, so we can actually figure out what are the ingredients, or what are the particles that is inside of that thing. Like for example, a cookie. So it has a flour, it has a sugar, has a brown sugar, has a chocolate chips, butter, baking soda, thus creating a cookie. Okay. But if you're going to, go deeper, like, let's just focus on the sugar, let's say this one. This one still contains another element, okay, wherein this one contains carbon atoms, contains oxygen atoms, and then hydrogen atoms. Wherein, as you guys can see, this one is like parts of our periodic table of elements, or you could see that this one is a single element, carbon atoms, and then another element, which is oxygen atoms, and then another element, hydrogen atoms, which is now inside of our periodic table of elements. Okay. So even the screen that we have right now, or that you are watching, where you are watching maybe your phone, or maybe your laptop or desktop. So your screen, your my bottled water, my paper right here, anything, okay? All of them composed of an element that is under periodic table of elements. Okay, so you can extract it to its most little or smallest part, wherein it could be hydrogen, could be lithium, could be beryllium, boron, carbon, and so on and so forth. That can be found on this table of elements. All right. So even the ice that we have right now. Okay. So it has an oxygen atoms, carbon atoms, hydrogen atoms, phosphorus, nitrogen, and so on and so forth. But we can go deeper. Okay. Like for example, a calcium atom. So of course, there's a lot of calcium atoms, and if you're going to zoom it in, or figure out more what are the particles inside of the calcium atoms, okay, that's where you can find a atom, or a single atom. So we could say that this one is composed of millions of atoms. Okay, this one single calcium atom. Okay, so this is already an atom, but there is a deeper, a smaller part of that atom, which is a single atom. Okay, so in here you can see that it is a human hair is roughly 500,000 times wider than an atom. So our hair is already super thin, like it's hardly seen by our eyes. And then make it much more smaller, 500 times. That's the size, or roughly, okay, that's not exactly, but roughly the size of an atom. Okay, so this is just a sample image, okay, just an assumption image coming from our calcium atoms. Okay. So we have a lot of kinds of atom, but if you're going to zoom that one in, so later on you will see what is the correct color, or the actual color, okay, of an atom. All right, so let's go back to the 400 BC. So as you guys can see right here, this is Democritus. wherein he came from an idea, like you can cut an apple, and then you just keep on cutting it. Okay, have to have like infinity until there is this part that you cannot cut it further anymore. Okay, so in that time, he assumed that yeah, until the part that you cannot see it anymore, that you're still cutting something. Okay, he assumed that that is already called atom. Okay, and before it's not called atom, but he called it atomos. Okay, so from here, just jump right here. He called it atomos, wherein he said that atomos means uncuttable in Greek word. Okay, but due to lack of evidence, so many people rejected this idea. Well, he just came out with an idea on what are the things that we can find if we keep on cutting something, like for example an apple, and then yeah, until he cannot cut anything anymore, and then that smallest thing that uh, he cannot cut is now called atomos. Anyway, that was long time ago, 400 BC, so he wasn't able to uh, not encourage, wasn't able to what do you call this one? Mm, ang proper term, hindi niya nahikayat, hindi niya na kalimutan ko yung term. Hindi niya na anyone guys, ang gusto kong iparating. Na-encourage yung naiisip ko pero hindi niya na-convince. Yeah, tama. Miss Lanila. So he wasn't convinced. He wasn't able to convince the people around him that the smallest thing that we cannot see anymore is called atomos. Okay, so moving on. We have here 780 after that, which is I don't know if this one is a historian or scientist, but he is Jabir ibn Hayyan, so maybe he is a scientist. So he have this process wherein from seawater, okay, you can form, so you just keep on, putting on fire and then forming a salt, okay? But he developed, or he figured out another process on how to extract smaller particles or smaller elements inside or of that element, let's say salt, okay? So as you guys can see right here, he has 4 processes. So filtration, boiling, and then vapor collection, and then cooling. So from that part, you figure out that you can find out more elements or particles on one thing, okay, or on a specific thing. Like for example, a fruit. This one contains a water. This one contains an alcohol. This one contains an acetic acid, a sugar, a pulp. Okay, and he wants to figure out more what's inside a water. Okay, so that is now where Antoine Lavoisier, I don't know if I pronounce it correctly, but this one is a French name, and Marie-Anne Paulze. Okay, so this one is 1700 AD. Okay, so they wanted to expand the idea of Mr. Jabir bin Hayyan. Okay, so from the water, okay, he wanted to figure out what else more that we can find on the water. Okay, so they figure out, okay, that they can still extract more elements, the individual elements, like called the hydrogen and then oxygen, okay, which now leads us to the elements, which is the primary constituents of matter that cannot be created or broken down through normal chemical reactions. And then, of course, they didn't stop there. Okay, so they wanted more to figure out what's inside. Okay, what are the particles of hydrogen and oxygen? But as time goes by, they failed. They cannot extract any other elements anymore or any other particles. So instead, they just listed this one as the smallest particles for now. Okay, so they listed it on maybe. So before, they don't call this one periodic table. This is just a list of elements. Okay, so they've started with H and O until they figure out another elements and then keep on adding that one on the list of the elements. Okay, and then as time goes by, before until right now, so as of now, okay, we only have found 118 elements. So when we see elements, that is a particle that we cannot divide anymore. Like it doesn't have any particles or any other elements on that element anymore. So it's like an individual element, okay, that you cannot cut anymore. Okay, so that is why we have this periodic table of elements right now, coming from the ideas of Mr. Jabir and Mr. Antoine Lavoisier, and then Miss Marie-Anne Paulze. Okay, so first the atom. So as time goes by, actually we are just assuming that we cannot really see an atom. Okay, it cannot even be seen by a microscope. Okay, so that is why they cannot show a single picture of an atom. But there is this one guy wherein they figure out how to scan, okay, how to touch, how to measure its size, okay, and then what does it look like. Okay, so the or someone invented scanning tunneling microscope, okay, wherein this microscope will be able to pinpoint one single element. One na nga single pa. Well, one element or a single element. Okay, and then what they're trying to track in here is the size. So as you guys can see, the green right here is actually the light, and then the red right here is the reflection that is coming from this nitrogen atom. Okay, so this microscope or scanning tunneling will move little by little para makuha nila yung size hanggang sa tatamaan dito, magre-reflect doon. It will hit this part and then it will reflect there. It will hit this part and then it will reflect there and then again until they will be able to, you know, see the size of it to its smallest part or smallest point. Okay, until we have captured this image coming from this scanning tunneling microscope. Okay, wherein we have this part. Okay, I don't know if it's red, but they said that this one is just an image processing picture. But every pixel, as you guys can right here, the red contains the process of every light that it hits. So if you're going to count the pixels, that's how many times it hit the light, the atom. Okay, so they didn't say the specific size, okay, the specific size of the atom, but it's roughly where is it one? It's roughly 500 times smaller than of a human hair. Okay, so yeah, sobrang liit. Okay, so that's now going back to the original form wherein this atom contains an electron, nucleus, protons, and then neutrons. All right, so did you guys learn something from the short history of an atom?
Yes, sir.
Yes, sir.
Yes, sir.
There is another thing that I find.
Yes, sir.
So when we say atom, marami palang klase ng atom. Okay, so this is just the image of a nitrogen atom. Okay, so atom na to, isa lang to. Meron pang atom na, saan na yung mga atom kanina to? Meron tayong, we have calcium atoms, we have nitrogen atoms, we have phosphorus atoms, we have hydrogen atoms, etc., etc. So all of our elements contains an atom, wherein it is the smallest part that compose of that single element. Okay, like for example, this hydrogen is maybe composed of 500,000 atoms. This helium is composed maybe 400,000 atoms, and so on and so forth. So all of them has their own individual called atoms. Okay, like indivisible element. Okay. All right, so let us now move to the electronics, which is the main topic of our module 3 or discussion for today. So what is electronics? So it is derived from the word electron mechanics, which means to study the behavior of an electron. Okay, so before, this is how they call someone that is studying about electron. But as time goes by, okay, they generalize it or categorize it to as electronics only, because we have a lot of different parts or specialists for expertise when it comes to electronics. So later on, you will know what are the branches of electronics. But before, it's just one, which is called electromechanics. But as time goes by, it's now generalized as electronics. Right, so the device which controls the flow of electrons is called the electronic device. Okay, so any device that has a flow of electrons is called electronic device. Okay, so you can see that all of our appliances that uses electricity is called electronic device. Okay, so these devices is the building block of electronic circuits. Okay, and the motion of electrons through a conductor gives electric current. Okay, so it could be done by a source of power, like for example, batteries or generators, okay, or any source of power or electricity. Okay, so once there is a source, of course, it will keep on providing or giving you a flow of electrons, okay, which is now called the electric current. Okay, so let us now move on to the branches of electronic. So as I'm saying a while ago, we have a lot of kinds of electronics. We have digital electronics, which deals with digital signals. So this one is just like maybe one of the new findings when it comes to electronics, because before we're only using analog, okay, analog electronics. But then there is this digital electronics, which is much more reliable due to, you know, lesser error and lesser noise. Because as you guys know, when we say digital, it only has two value. Okay, it could be 0 or 1 only. Okay, so example, this one is continuous, the signal transmitted as a sequence of ones and zeros. So it can be reconstructed without error. So yeah, very, very reliable. But you know, analog is still reliable, especially in some cases wherein we really need a real-time variation, wherein from point to point. You can say that analog is the AC input. Okay, it varies from time to time. Okay, 0 to 180 to negative 180 and so on and so forth. Okay, so like it records everything. Okay, so systems with continuously variable signal, of course. So like for example, an analog clock. Okay, so there's a lot of variation or there's a lot of noise that is coming from an analog because it works via mechanical. Okay, like for example, our wall clock, that is an analog. Okay, so there's a lot of factor. What if there is heavy heavy wind? Okay, so it might affect the swing of the clock. Okay, so that is one factor, or that is one noise that you could say that it will affect our analog clock. Okay, so have a continuous varying signal. So yeah, it transfers from one medium to the next, like mechanical inputs. Building. Hala ko may nabura ako. Kinig ko pa rin ako, Control C. Anyway, so yeah, that's it for the analog and electronics. And we have here microelectronics. So from the word micro, okay, so it deals with small electronics, okay, design and components. So in here, it is now under or in here we have components which is under microelectronics, which is the transistors, capacitors, inductors, resistors, and diodes. Okay, or even insulators and conductors. So those are actually the basic components that you'll be using to make a single device or a single system. Okay, so all of them is under this so-called microelectronics. Okay, and then here are the other branches of electronics. So we have IC, integrated circuits. So you guys know that this one composed of many circuits or many components, okay, to form a single circuit, which is called the IC or integrated circuits. And then we have power electronics. We have optoelectronics, which deals with light, telecommunications, which deals with signals maybe or communications. And we have semiconductor devices, embedded systems, and then audio electronics. Okay, so these are just the other parts, which I will not explain anymore since we will not be discussing the fundamentals or the basic of what is power, opto, and then telecommunications. So maybe integrated circuits. So this is the only one that we will discuss a little bit more. Okay, so before that, let me just tell you guys that we have two types of signals. We have the AC and then the DC. So since you guys are already third year, am I right? Third year or still second year? Hello guys. Ano na kayo? Second year or third year?
Third, sir.
Regular, sir.
Yung iba, sir.
Third tapos merong second, no? So yung most of you are already done with electronics. Okay, subject electronics. So be sure ha. Di ka sure kung second year or third year na. Okay. Anyway, so you guys want to know what is an AC. So this one flows alternately. And we have DC which only flows in one direction. Okay, so it could be negative or positive only. But mostly when it's DC, it's positive. Okay. And of course, when you see AC, so it's recall. So it has an amplitude, of course. So it could be 60 hertz, 100 hertz, 20 hertz, etc., etc. And then let's say you have a voltage. Where's that one? I know there's no given voltage. But when I say 60 hertz, this one is reversing 120 times per second. Okay. So 60 for the positive and then another 60 for the negative. But for the direct current, so nothing. Okay, it's just the voltage that is given. So it will start with 0, of course, and then the voltage given. So it's constant. Okay. And then voltage and current. So you guys are aware of this one. Voltage is rated in volts, and then current is rated in amps. So this is just an example. So 9 volts and a current of around 500 milliamps or milliamps. Okay. And then we have here the types of circuit. So I'm pretty sure that you guys already know this one. So as always, when we see electronic devices, so it's always a closed circuit. You could not say that it's an electronic device if there is no loop of current. Okay. Yeah, you could still say that that one is an electronic device, but that one will not work. Okay. It's just a bunch of components. Okay. Unless there is a flow of current or it is a closed circuit and then current will be able to flow on that circuit or on that electronic device, then that's the time that we can say that it's an electronic device. Okay? And if it's an open circuit, then this is just two components. So we have here the probe or the wire, and then we have here the LED. Okay, this one is not an electronic device. Okay? So we must have a closed loop for us to be able to say that it's an electronic device. Anyway, so they are just types of circuit. And we have here the series versus parallel. So you guys want to know this one. For series, there's only one path or one flow of current. Okay, so component, next is component, another component, etc., etc. And then we have here the parallel. So this one is wired side by side. So I hope that you guys want to know what is a parallel look like. Okay, so it has a node, okay, and then branches inside of it. Okay, and it has many paths, or your currents will split into many paths. Okay, and we have here the common basic electronic components, in which you guys maybe already know most of this. So we have resistors. Pretty sure that you guys already know this one, and we have capacitors. So alam niyo na rin to. LEDs, transistors, inductors, potentiometers, and then integrated circuits. Okay, so we could say that the one that we're trying to, our goal, okay, in this module is to create similar like working integrated circuits. Okay, so integrated circuit is composed of many components inside. So it has resistors, transistors, capacitors, etc., etc., which is programmed to do something. But in our case, since we are starter or beginners, so we will start with individual resistors, individual capacitors, LEDs, and transistors, and inductors and potentiometers. And if you want to use a certain IC or integrated circuit, so no problem, as long as you know how to use that one or what is a specific model of that IC. All right, so any questions so far up to this point?
None, sir.
None, sir.
Okay. So since you don't have, okay. So if you guys do not have a question anymore, so you guys may go for now since we don't have enough time anymore. So I guess we only have 20 seconds left. So just see you guys on the part 2. Okay. So wait nyo lang kaagad. After neto, popost ko na yung new link. Then join na kayo kaagad. So again, you guys can eat while listening and watching. Okay. So goodbye for now and see you guys later.
Bye,
Yes, sir.
sir.
Bye.
Bye, sir.
Sir.
Bye.